like
everything.
I only go
everything before COVID.
Semi-regularly.
Yes,
but,
exactly.
But he was like, please say hello to Saul for me.
Well, thank you for coming.
Yeah.
It's nice to have
It's
you
fun.
here.
I'm very excited to come and have a nice STS crowd to play with and to be so no, it's great. And it's a flying visit. I mean, I got in last night.
You got in last night.
Yeah, it takes all day to travel from Phoenix, basically.
Yeah.
I think my flight was at 10 a.m. and I got in at 9 p.m.
Through
Charlotte.
Okay.
She's going tomorrow to hang out with another person who was in the postdoc with Sheila. So Emma and I were in.
Oh, you.
Our offices were next door. It was like you, me, and Maggie, just like
And then our friend
And
Maggie's
who?
now in Maggie Crenute is now in industry. She does regulatory affairs stuff for pharma companies.
Yeah.
Okay.
But we were the two postdocs that year, I think, right?
Yeah, we were the two postdocs that year. That's right.
Very cool.
Yeah.
Going way back.
Many late night drinking sessions.
Some things to talk about.
Yeah, we did have some things to talk about. Yeah. So.
No, I'm not.
Yeah.
If you're worried,
So.
I'm not.
I'm looking forward to your talk.
Yeah. Should be fun.
Glad that you were able to make it here for a.
I know, we've been trying for.
Yes, like a
Well,
couple
well,
years.
Sonia was like last year, and I said, look, I'm on sabbatical, and I'm not going to fly across the pond for this. And then the fall was just insane.
Yeah.
I think I had 5 trips last fall, and then Jamie had about 4. So it was one of those situations where, like, basically every week we were just handing off, and I was like, I can't,
With a kid.
I can't do this. And so,
You have one kid?
Yeah.
Yeah. How old?
6.
Okay, so that's.
I mean, it's easier now. Like I can be like, I'm staying for the weekend, and James was like, that's fine. But still, you can't just leave them to their own devices for a week. And,
There's still,
and we don't have grandparents in town or anything, anything like that. So.
Saul's got 2 older kids. One's finishing college, right?
One's finishing college and one's finishing high school.
There you go.
So one is still at home, and the other one's about to return.
The other one was in
home?
Edinburgh.
According to who?
The college student went to college in Edinburgh.
Oh, really?
Yeah.
Oh, wow. That's
He's
where.
staying in London next year.
Fantastic. Yeah, I was in Edinburgh for 10 years
Oh, were
before
you?
moving out to ASU. Yeah. That's where I
That's where you.
got my STS
Yeah.
trial by fire.
So he's in sociology, and so he has some interaction with the STS folks, but isn't.
Yeah.
In,
Yeah.
So he's
It's its own building in
yeah,
Denver.
but he's taking an STS course this semester.
Is he?
It's kind of funny, and they had some.
Dad, I'm reading.
And he went up afterwards. He said,
My
"Not to be a nepo."
right. But then,
Very sensitive about
but is he also is he like, oh, Dad, this means like you actually,
You're real.
you're
Yeah,
famous
no,
at
I'm
it.
not sure what the response was. It was just a little disorienting.
Yeah.
One of my younger brothers, he finished college not that long ago, like 3 or 4 years ago. But he was a psych undergrad, but he took some sort of bio course, and they watched a video of gene drives, and it was do you know Andrew Maynard? He does like these risk bite videos.
Yeah.
And so he's at ASU, and so anyway, he credits me at the end of the video, and my brother's like, holy, he said the same thing. He's like, we just watched this video. Like,
Is he too?
Because once we start this, we can't let people in the Zoom. That's not.
Oh.
That's not in our. So I mean, we would have to like.
Yeah.
Come off of her
So as long as
slides
I'm
and stuff, so-
as long as I'm set up as a co-host, I can let people into Zoom.
Yeah,
I'm doing a
I'm always the one that usually just did all that. So.
I would be going.
I'll be right. I'm signing in now.
I don't want to do work on something before that. No, he's traveling.
Oliver's traveling. Someone's got to let me in, though. Can I be let in to let others in?
Are you gonna have 5-10 minutes after this?
Joe, can you let me into the Zoom room?
They can probably wait. There's various update things.
I love that. It goes to infinity like that. Yeah, I'm in. Janet's saying we're still muted. Okay. Matt, are you signing in?
It says host has joined. We let them know you're here. I'm being signed.
Someone's going to have to let...
Yeah.
Oh, here's Matt. Let me see if I can...
And do you want me to moderate and just say there's a question on Zoom or whatever?
Oh yeah.
Yeah.
I was gonna say, do you want me on Zoom so I can see?
No, it's okay. Hey, Matt, or Joe, or Mandy, do you have the ability to make Matt W. a co-host? All right. You got it, Matt? Thank you so much. Are we ready to go, folks? Okay, ready? We're good? All right. Hi, everybody. Welcome to the STS seminar here at Virginia Tech. My name is Lee Vinsel. I'm one of the organizers of the STS seminar, along with Fernanda Rosa and our trusty graduate assistant, Oliver Shuey. Today we have Emma Frow visiting us. And Em, I want to say that Sonia Schmidt has been working hard for a couple years now to get Emma here. And one of the reasons I want to say that is because I have a policy against bringing old friends of mine to give talks. But Emma is now at ASU, and she has a joint appointment in the School for the Future of Innovation and Society and the School of Biological and Health Systems Engineering. And Emma has a very interesting and impressive background. She got a PhD in biochemistry at the University of Cambridge and did editorial work at the journal Nature for a couple years. I called her an editor, and she said she was a sub-editor. But still, she worked for a while at Nature. And then she ended up at the University of Edinburgh, where she kind of trained up in STS and actually had a faculty position lined up at the University of Edinburgh, and maybe even did that for a couple years.
3 years?
Yeah, exactly. We overlapped as postdocs at Harvard's STS program, and then she landed this job at ASU. And she's been very impressive in a number of ways since landing there. She's landed a bunch of NSF grants and pulled down that cheese. And has been very successful in that way, and has been doing a lot of fascinating work at kind of the around synthetic biology and bioengineering of all sorts. Today, she's going to talk to us about ongoing work she's been doing around biofoundries, with a talk titled "Reconfiguring Life, Care, and Control in Bioengineering." So, thank you for joining us, Emma.
Thank you. Thank you so much, Lee. And it's just lovely to be here in an STS department. I'm really excited to be able to share some work with you and connect with some old friends and hopefully make some new friends and some new colleagues. As Lee said, I'm going to talk today about synthetic biology, and specifically I'm going to take you into the world of the biofoundry. And this is a world that I've seen emerge over the past 15 years. So I've been sort of first dipped a toe in synthetic biology about 15 years ago, and this is sort of a development that I've seen emerge over that time, moving both between the US and the UK. So these biofoundries are springing up in universities around the world. They're also at the heart of a number of synthetic biology companies. And at the moment, I have a 5-year NSF project to study and engage with these facilities. So I'm about halfway through the project, which means that there's lots of threads and rabbit holes and things that are emerging that I'm sort of traveling down. And this seminar has been a really nice push to try and bring some of it together, try and make sense of a few things. It might be a little bit messy. I hope you will humor me, and I hope that the conversation today will push me to refine some of these ideas. I'm just going to try and focus on a couple of things that have been emerging lately. So I think, one obvious first question is sort of what is a biofoundry? And there are lots of different ways that one could answer this question. So I think what I'm going to do is give you several partial answers or several partial definitions or ways of reading biofoundries over the next 45 minutes or so. So at a technical level, the goal of a biofoundry is to bring increasingly advanced automation tools and high throughput practices to the work of genetic engineering. So think fancy machines, robotic arms like on the picture here, and also increasingly AI. And one of the stated motivations for doing this is to be able to more robustly design and engineer cells and organisms for human wants and ends, right? I think a different and still partial answer to the question of what a biofoundry is, as somebody who's been sort of watching the field of synthetic biology for 15 years, is that it reflects a reframing of the failure of the vision of synthetic biology. So the initial vision of wanting to rationally design with DNA. And if it becomes challenging, if it turns out that it's really hard to rationally design your way to new biological capabilities, maybe you can brute force your way by building and testing thousands of samples in parallel to get yourself to the functions or the behaviors that you want. So a third, and again, slightly different way of thinking about biofoundries is that they're an effort to capitalize on the existing capabilities of molecular biology and growing biological data sets and reflect an attempt to sort of reconfigure these elements in new ways so as to extract or create value. So one of the foundational ideas of synthetic biology as a field is that the stretches of DNA contained within living organisms can be broken down into functional parts and combined in new ways to create new functions, right? So biofoundries, in a way, are a sort of infrastructural attempt to manage and derive value from this kind of complexity. If taking as an assumption that you can break biology down into this genetic componentry. So what you do is you bring in machines, hardware, and you bring in software that lets you design and build and test hundreds or thousands of biological samples in parallel. These samples might be DNA sequences, or they might be DNA sequences that have been put into cells, usually microorganisms, yeast or bacteria, but sometimes mammalian cells. And then you select the most promising ones and you feed them back into your system, increasingly using machine learning to help you design your next iteration. So the biofoundry is really focused on sort of building this physical and digital infrastructure to allow this kind of high throughput and systematic experimentation with different biological combinations. So you clearly need machines, you need software, you need biology, or sometimes the synthetic biologists call this wetware. You obviously need people, and then of course you need meaningful flows of data between these various elements. So when we look at pictures of biofoundries, it's often the material aspects that stand out, right? That first slide I showed you of the Edinburgh Genome Foundry had these robotic arms in the middle. Here you see images from 2 biofoundries based in academia and 2 based in industry. I always like to play the game of going to the biofoundry websites and seeing how many of their images include people, because a lot of the time they're devoid of people, as you can see with the examples here. And as I suggested, obviously the biofoundry is a lot more than physical equipment, right? Something that wouldn't be of surprise to this audience, but turns out to be a bit of a revelation sometimes with a more scientifically inclined crowd. So to give you just a very brief sense of the biofoundry landscape, there are currently over 30 members of an academic network called the Global Biofoundry Alliance. This number is growing year on year. The NSF actually currently has an open call to fund an additional 2 to 4 biofoundries in the US. I'm expecting they'll make their announcement of which ones were successful in the next couple months. So there's going to be more, added to this list even in the US. Now, these foundries are mostly based in North America, Europe, and Asia. There's some biofoundries beginning to really come into play as well from Australia. For their initial construction, usually they secure grants of somewhere between about $3 and $10 million. And typically most of that money is spent on equipment, basically fancy robots. There's often a renovation budget as part of this because these facilities are often retrofitted into existing spaces. Old libraries, former labs, basement rooms. They often require different ventilation structures, maybe reinforced floors and things like that. But of course, to run a biofoundry, you also need people, obviously. So most of the academic biofoundries have a core staff of somewhere between 4 and 10 full-time employees. For the most part, these employees or these facilities are positioned as core facilities within their universities, if this is a term that you're familiar with. Most institutions, Virginia Tech has core facilities, similar like microscopy facilities, maybe a nanofab lab, protein purification facilities, and so on. So the imagined user base for these is projected to come largely from the local academic research community, right? Maybe not restricted to your institution, but the kind of idea is that it's sort of a local service. The biofoundry model is also at the heart of a lot of small and medium-sized synthetic biology companies. So as part of my project so far, I've been focusing on academic biofoundries as well as some of these larger commercial biofoundries. So ones that have over 500 employees and are publicly traded on the stock exchange. So this is a quick overview of what I would say is the 3 biggest biofoundry-based companies in the US. I am hoping to visit some smaller companies that have these kinds of facilities as well. But most of these biofoundries that I'm looking at sort of present themselves, this is sort of something we'll get into, they present themselves as service providers. What it means is that they are not in the business of developing and commercializing individual products. So they're not making and selling drugs or fertilizers or laundry detergents. What they're doing is the upstream genetic engineering work for laboratories and companies that are commissioning those services. As you might glean from this slide, if you've been looking at it, this isn't necessarily straightforward. So 2 of the 3 big US biofoundries have declared bankruptcy in the past 2 years. So Zymergen got bought out by Ginkgo Bioworks in 2022, and the company Amyris filed for bankruptcy about 6 months ago. So at this stage in their development, I would say biofoundries are very much in flux. They're simultaneously trying to figure out how to engineer biology at scale, what a successful business model looks like, and what kind of culture and ways of working they want to promote. And so, the nice thing here is that from my perspective, each biofoundry is essentially its own experiment, right? There aren't yet simpler, well-defined ways of doing this work. And as you look across foundries, you can start to see lots of differences in how they approach their work. So lots you could say about the individual design decisions that are being made across different foundries, tons of rich STS material for people who are interested in the relationship between infrastructure and values, or debates about automation and the future of work, those kinds of questions, right? Because each one is sort of trying to structure itself slightly differently in pursuit of this imagined value. So today I'm going to focus on articulating some of the visions and aspirations for these foundries and then explore how they're playing out in practice. When you look across policy reports, news articles, and funding bids for biofoundries, a lot of the aspirational language that you see relates to sort of these 3 interrelated issues of scale, time, and work. So examples of the kinds of visions you see being put forward include things like, as I mentioned, like scaling up genetic construction and testing, but that also means like more samples at greater speed. There's a sort of temporal element here. We also see different ideas in play that all point to potential changes in the nature of work. So not necessarily eliminating it, but maybe centralizing the work of genetic engineering, or improving reproducibility, that big kind of crisis in science right now, de-skilling work, perhaps creating hierarchies or divisions of labor that separate out the creative design process from the manual labor that's needed to produce genetically engineered products. And sometimes you see this carried out into the sort of the personnel within a biofoundry who might be divided into design teams, build teams, test teams, and so on, sometimes physically separated as well. And all of this is really about, it's like freeing up time to focus on creative design. And so they're sort of trying to reshape this like scale, time, work nexus. And then in doing so, biofoundries also start to make claims about their broader societal impact. So they position themselves as being able to turbocharge academic research, change the nature of research projects, contribute to a set of broad, underspecified, grand challenge-like problems, right? So you can see these social aspirations emerging around climate change, sustainability, contributing to a more bio-based economy. They emphasize their potential to make valuable contributions to things like producing biofuels instead of fossil fuels, or using yeast to make compounds that you would normally get from, say, sharks. So right now, a lot of the conversation is focused on sort of I would say it's drop-in replacement or substitution of existing products is where a lot of the activity has been. While there's this basically a focus on drop-in replacement, biofoundries also present themselves as this sort of challenging, disruptive, innovative force for bioengineering research and biotechnology writ large. And I think one of the sort of things they often trade on quite problematically, in my view, is harnessing the potential and biological diversity within nature. And they often talk about things like moving us from a place of current scarcity into a future of abundance. Yeah, no, and it's, yeah, I think I have a quote. I think I have a quote that shows that nicely in a couple slides, actually. So, this is the kind of vision that gets painted, right, about it. But, just to bring us down from this 30,000-foot rosy picture, one counterweight to this ambitious vision is the practical and, maybe somewhat philosophical question as well of whether the complexity of biology can really be tamed in the way that biofoundries are envisioning. And it's really interesting, actually. In a conversation just, I think, 2 weeks ago, a biofoundry practitioner in a commercial biofoundry reminded me of this article that was published in 2010 called 5 Hard Truths for Synthetic Biology. And they noted that they had recently been reminded of this article themselves and that every single hard truth identified back then was turning out to be true. So, so this sort of, we're thinking about this sort of 15-year vision of trying to make biology yield to this, the complexity of biology yield to this. So in many ways, the biofoundry is kind of an ambitious and I would say audacious project. It's one that proposes value creation, or maybe you would say value extraction, from breaking down biology into genetic components, mining the diversity in this genetic componentry, and then using the raw material to build new products. So maybe there's another reading or definition of biofoundries to sort of introduce here, right? That you could see biofoundries in a way as the sort of colonizing project that Anna Singh describes in her theory or in her paper around non-scalability. So akin to taking sugarcane plants out of their natural environments and moving them to Caribbean islands to create large-scale standardized socio-technical systems called plantations. So it's a process of remaking the relationships among biological elements, one that potentially risks cleansing nature of its transformative social relations in pursuit of value. So to sort of pick up on that and change tack just a little bit, I realize I've been doing a lot so far to kind of just introduce what biofoundries might be. And so maybe this is also a place to kind of stop and share with you a little bit about the theoretical and practical approaches that I've been taking to study these facilities. So I've framed this broader project around exploring the relationship between care and control as it plays out in the development of this infrastructure. So, control is an aspiration that sits at the very heart of biological engineering. The idea that DNA can be decomposed into functional elements that you can abstract from the living organisms that they were part of and then selectively recombine them in new ways, I mean, that really is all about control, right? But I think these biofoundries are the site of lively reconfiguration and revaluation in biotechnology. They're striving to extract new forms of value from the living world. And this reconfiguration is all about restructuring the relationships between humans and DNA as mediated through this physical and digital infrastructure. And so this interest in following the complexities of negotiating these relationships is sort of what led me into scholarship around care. And so my approach to care is inspired from feminist literature concerned with the practices that are needed to build and sustain and sort of repair our world and the infrastructure in it so that humans and non-humans might thrive. So I'm thinking here about authors like Joan Tronto and Maria Puig de la Bella Casa, who discuss care as an affective practice and as an ethical practice and a political labor. And that involves the negotiation of complex relationships between those who are sort of doing the caring and those that are being cared for, right? We all know that this can be fraught. Like being in a caring relationship is not necessarily a straightforward one or an easy one. So I'm not sort of attaching myself to approaches to caring that are just thinking about that sort of very sort of feminized, positive vision of care, but examining the sort of charged affects that are involved in negotiating this sort of set of relationships at heart. And I think attending, this sort of focus on care coming out of feminist STS as well also really encourages us to attend to who and what is being left out in the process too, right? And then the work that I'm going to share today is also really attempting to grapple with the relationship between scale and non-scalability, which I sort of hinted at a minute ago, described by authors like Anna Singh. In the case of biofoundries, I think there are strong parallels between control and care and scale and non-scalability. I'm not suggesting that they're equivalent, but I think these biofoundries are explicitly attempting to engineer biology at scale. And I think these questions of scalability are quite tightly bound up with questions around control, and then thinking through that relationship. And then care and non-scalability, I think, have these elements that sort of resonate. So when attending to the politics of care, similar to that, I would say attending or exploring or attending to non-scalability, both of those are drawing our attention to what gets left out, or what spills over, or what is resisting hegemonic framings of scale or control. We see that non-scalability is often tied to context dependency, as is care. Care is a very context-dependent act. An act of care in one context might be received very differently in a different context, right? Could be very damaging in another setting. Similarly, care is not a straightforward good, nor is scale or non-scalability, right? Anna Singh similarly says, this is not about just identifying winners and losers. This is about attuning ourselves to the kinds of relationships that are being forged through these world-building activities, and to think critically about the sorts of worlds that are emerging. So in studying these biofoundries, I'm trying to be kind of particularly sensitive to the affective dimensions at play, really focusing on how the relationships between different elements of this assemblage are coming together. And I'm also drawn to kind of thinking with the politics of care as a way of informing my own practice, right? So in Maria Puig de la Bella Casa's work, she really offers care as what she calls an ethico-political orientation for STS researchers, and as a way of trying to move beyond critique at a distance. And the kind of orientation that she is suggesting is one that I find myself very, kind of becoming deeply involved and complicit in this world of biofoundries in ways that I think her sort of call to thinking through this from the perspective of the politics of care is a very useful guide for me here. So methodologically, this project draws on qualitative mixed methods. I would say it's probably best described as a multi-sited ethnography, although I'm a little hesitant to call myself an ethnographer because I've never actually been trained in ethnography. But I do really appreciate the descriptions of multi-sited ethnographies that scholars like Kim Fortune talk about, where they describe the need, especially in our late industrial age, to develop practices that help us move across scales and look for discursive risks and gaps that become visible as you shift across these sites. And so what I will try to do today with the material is to weave across these scales as well, of sort of vision and practice and so on. And I also really appreciate the idea of trying to mobilize ethnography for intervention. This is something that I have done in the past with colleagues in the UK in sort of fairly creative ways, and some of those creative interventions are starting to be developed here too. But I also, so far in this project, have done a fair bit of writing of various forms with biofoundry practitioners. So that's kind of one way in which that intervention is emerging. So far, I would say I've engaged in different ways with probably 10 biofoundries, combination of short visits, some more extended stays, and in our wonderful age of Zoom, remote interviews are much more possible as well. And one of my PhD students also did some field work and some interviews in 3 commercial biofoundries as part of a different grant, and I'll briefly mention a couple of her insights later on. So her conversations have really informed my thinking here too. And I would say because biofoundries are this very active site of experimentation right now, I have found a lot of interest on the part of practitioners to engage with my work. Access has not been a problem, and in fact it has led to conversations, and so many conversations emerging that it can be sort of tricky to keep keep all of those threads going. And I think this is also in that spirit of moving beyond critique, I'm sort of committed to engaging with the system in ways that go beyond extractive research, right? But really help to build some capacity for reflection and change. Actually, I've given a lot more talks about biofoundries lately to biofoundries than I have to, STS audiences, right? So happy to chat about the opportunities and the challenges of that kind of positionality if that's of interest to anybody. And also I think this ties in, as Lee mentioned, I have this joint faculty position at ASU between sort of the STS department and the bioengineering department. And so again, this is my work really does sort of attempt to find ways of bringing STS into the bioengineering, into the worlds of bioengineering, kind of thinking and practice in multiple ways. So they sort of align. I'd say this is it's an important part of my work. So for this project, my research involves visiting, spending time in academic and commercial biofoundries and looking at these sort of everyday practices of care, right? Routine tasks like managing a team, caring for laboratory organisms, maintaining equipment, curating data. These are all critical to success in the biofoundry. And so I'm hoping that, doing this sort of, deeply ethnographic work will help to uncover some of the ways in which life and value are being recalibrated. But I think attending to care also asks us to look at the broader context, the relationships, the power distributions that are enabling and sustaining these kinds of, formations like the biofoundry. So I'm also trying to do work that's tracing kind of the broader political economy around their emergence, right? What are the visions animating investment here? What kinds of resources are going into it? What kinds of governance repertoires are being drawn upon, and so on. So what I'm going to try and do for the next 20 minutes or so is try and knit between these two scales, drawing on both how the biofoundry is being constituted and how it's kind of internally calibrating its work through that process, right? So it's kind of a process of alignment, right? Okay, so back to the biofoundry. One question that comes up a bit that I think is a really interesting one to think through is there anything different? Are they anything different from just another biotech company, right? I mean, what makes a biofoundry different? I'm not going to try and definitively answer that question, but I'll give a couple of observations that I think are kind of interesting ones to think through. The first is that I think biofoundries are entering a biotech landscape that has been largely organized into some fairly clear sectors: medical biotech, ag biotech, industrial biotech, environmental biotech. And typically a company will work in one of those sectors, maybe two, right? But what biofoundries are positioning themselves to contribute sort of across sectors. And they do this in a couple of different ways. So first, they're pitching themselves as service providers, and they're not necessarily tethered to one sector. They offer genetic engineering services to clients, biotech companies, academic researchers, and so on, but they're not actually manufacturing the products themselves, right? So they're doing some of that upstream work, and then they can hand the materials on to clients across sectors. And then second, I think biofoundries sort of approach the work of biotech from a different angle. They sort of flipped things around and take a particular lens. So for example, rather than thinking about a particular class of products like cancer drugs or fertilizers, often what they do is something like orient themselves around a metabolic pathway. And then you can use all the byproducts of that metabolic pathway and put those intermediaries, figure out where those intermediaries fit in the world. And this potentially allows them to intervene across many different sectors. So this is just a quotation from Amherst that shows a few things, but this is these are products that they've worked on. Whether it's a breakthrough molecule for anti-wrinkle skincare, a zero-calorie sweetener, a life-saving medication, a fine fragrance, or a polymer that makes electronic circuits more effective, our technology platform will take us to new opportunities that we haven't yet imagined, right? For example, Amyris as a company initially developed great expertise in terpenoid engineering. So terpenoids are this huge class of molecules present in a wide variety of products. And so developing expertise in terpenoid engineering is what all of these different products here are sort of variations, include terpenoids, right? And so when it was first founded, Amyris actually had a huge significant focus on biofuels and the anti-malarial drug artemisinin. Then over time, they moved much more into sort of beauty and consumer products, as you can see from the list here. And of course, now they're in the process of bankruptcy restructuring. So, so who knows? But, but I think these are a couple of things that these facilities are doing that maybe aren't typical of biotech. So biofoundries are trying to frame themselves as these service providers across the entire biotech ecosystem, which is potentially a gigantic problem space, design space, right? So they're now faced with this really daunting task. Framing yourself as a service provider means that you've got to have customers, and ideally a large customer pool. And so biofoundries are doing the work of developing the platform infrastructure to design at scale. But the use cases or the specific applications come from the customers. And these customers are likely to be working on very different projects, low-calorie sweeteners and fertilizers and whatever, right? Using different model organisms, asking different questions, wanting different kinds of services. So biofoundries have to try and develop practices that are both scalable and flexible, offering to a diversity of clients the opportunity to engineer biology at scales that they wouldn't typically pursue at a time frame and a cost that seems reasonable to the client. And the engineering platform is still under development. So how much is this a case of building technology to attract customers, or finding the customers and building your technology? It's like, this is a serious chicken and egg problem at the moment. And in practice, it's very challenging to pursue both of these goals at once. And this isn't unique to biofoundries, right? Like this is, you could abstract this and be anything, right?
Yeah.
This is just a case where this is, it's a lively site to study this in practice, happening in real time. And I was particularly curious to see this slide presented by the CEO of Ginkgo Bioworks about 2 months ago at the JP Morgan annual healthcare conference. Believing that there is a false choice between scale and flexibility. So this slide actually prompted me to go back and look at some of my data with this in mind. So this is kind of the issue that I'm working through today. And I'll come back to this slide at the end. I just wanted to put it there as a provocation, and we will revisit it in a minute. Once I share with you some observations about how this tension between scale and flexibility is playing out in practice on the shop floor of the biofoundry. So let's look at some of the challenges involved in automating lab practices. A lot of biofoundries have as their core mission wanting to automate a lot of the work in genetic engineering. It should be said that not all biofoundries do. Remember, I said each one is its own design experiment. There was one biofoundry that early on actively made a point of not buying robotic equipment. Instead, they focused on really standardizing protocols and hiring undergraduates to work as robots. They even did time motion studies of the lab in order to try and optimize the placement of equipment and how to coordinate movements and so on, right? So, not everyone's going the machine robot way. But this ambition to automate lab practices raises lots of interesting challenges, I think, around scale. So the first one, I would say, is kind of a practical challenge related to the design of individual projects. And this one, I sometimes like to think of as scaling down to scale up. So in principle, biofoundries encourage you to experiment at scale, which means they want you to increase the number of samples that you're testing. So scaling up here is about increasing the number of samples. To do this efficiently, you would ideally decrease the volume of each sample. So we're talking about moving from the Eppendorf tube or the classic 96-well plates that have been very central to the work of molecular biology for the past 50 years, and shifting instead to plates that contain 1,500 wells. So this is the scaling down. So scaling down the volume so that you can scale up the total number of samples that you're testing. Now, the volume of each of these 1,500 wells is tiny. You're talking like microliters. So instead of using a traditional multi-channel pipette, which is that kind of image on the left, you need to move to fancy and expensive pieces of equipment like this Echo liquid handler in the middle, a several $100,000 robot, which uses sound waves to dispense nanoliter volumes of liquid into each of the wells on this 1,536 well plate, right? So you're sort of like tying the methods to the robots that are there. And this process of scaling down involves a lot of technical adjustments, because when you're scaling down a reaction from milliliters to microliters or even nanoliters for these 1,500 well plates, you're fundamentally changing the reaction kinetics within the sample. So it's actually a little bit like baking, right? You can't just cut all your ingredients in half, shove it into a smaller tin, and bake it for half the length of time, the same length of time, and expect the same cake. And so, you know, as an academic researcher, I can't just hand my protocols over to the biofoundry. The protocols have to be remade to become biofoundry appropriate. And interestingly, I haven't been able to find too many STS studies of lab studies of automation. It'd be interesting to, if anyone has any recommendations. But there is one from 20 years ago looking at the introduction of DNA sequencers. And at the end of the piece, the authors conclude that automation is not just about mechanizing existing protocols, but about fundamentally reconceptualizing them, right? And this is, you know, a very practical challenge that many biofoundries are currently grappling with, especially the academic ones. So when I first started visiting these biofoundries, they were always so excited to show me the equipment, right? Like all the robots they managed to buy, which were normally sitting unplugged, quiet on the lab bench, because it takes 6 months to a year to figure out how to integrate this machine into your workflows, right? And this, I would say this reconceptualization also isn't just limited to the technical aspects of scaling down volumes to scale up numbers. There's conceptual challenges too. So again, when I was a PhD student at the lab bench, I used those 96 well plates all the time. And I could, in my head, design an experiment for 96 wells, right? If you suddenly told me I had 1,500 wells to play with, it would take some reconceptualization of the kinds of questions I was asking and how to design an experiment for me to be able to do that, right? So you're actually also sort of asking or expecting researchers to make these conceptual shifts as well as the practical ones, right? I wouldn't necessarily have known how to do that, right? And if I hadn't been trained to think that way, it wouldn't be something I would naturally gravitate towards. I'm actually doing a little side study right now of users and active, or I'm calling them curious or skeptical non-users of biofoundries to sort of, again, try and understand what it is that, you know, kind of the ways in which biofoundries do and don't kind of fit into their frames of reference. But, you know, we have this chicken and egg problem, right? Biofoundries haven't had a long line of customers at the door waiting to use them. So as one practitioner put it at their 2022 annual meeting, the workflows are endless. How do you choose? Is it client-driven, or do you put a chunk of money aside and develop the tech first and then chase your clients? This is not something that's limited to the academic foundries who participate in this meeting. This photo here is a picture of what you would have seen if you stepped off the elevators into the headquarters of Ginkgo Bioworks in 2021. This astonishingly high throughput and automated facility that they purpose-built was for COVID sample testing to process 100,000 samples a day. But by the time the facility was ready to launch, the company had pivoted to building capacity for more distributed COVID testing. So when I visited in 2022, the handful of machines that were left in this space had Post-it notes on them that said keep or move or remove. And by 2023, this space contained a largely different configuration of machines. So the workflows and the machine configurations that you set up are tightly coupled to the kinds of samples you can process and then the sorts of questions you can ask. So this kind of leads me into another sort of point about this flexible scalability, which is, you know, relating to the properties of biology itself. So if your aim is to be a platform facility offering services to a wide variety of clients, you want to be able to accommodate the diversity of projects that your clients might come in with, right? So here scale is about sort of the number of individual projects. We have scale appearing in multiple different ways, right? But here's kind of like the diversity of projects. So, and in practice, in particular, when you're sort of setting up your biofoundry, each new project seems to demand a slightly different workflow. So here's another quotation from a participant at the 2022 meeting expressing concerns about this. So, well, the power of having this foundry is doing things over and over and over again and having things that are standardized so that you can accelerate and scale. If you have 20 people knocking on your door and they're all asking for something slightly different and you constantly have to develop or adapt your workflow, you lose that value, right? And this need, again, none of this is particularly surprising, but it's kind of astonishing that all of these facilities have been set up and are sort of floating, trying to figure out how to manage this, right? And the need to adapt workflows is partly because biology is so complicated and context dependent. And biofoundries typically work with living organisms, and it's not always easy to make life amenable to these scaling projects. And so again, one of the things you realize as you try to bring clients in is they show up and turns out very few of them work with E. coli. They work with yeast, Saccharomyces, a ton of them work with weird organisms. So you have to make difficult choices as to whether or not you're going to try and host that project, that client, or whatever, or basically whether you're going to say, no, these organisms are untractable, not adapted to a biofoundry model, so I can't do this. But again, as a biofoundry model where you're going to survive on multiple smaller contracts, turning some of these down is very painful, right? So it turns out, as you again start looking at the infrastructure, that you need separate facilities to work with mammalian cells compared with bacterial cells and compared with yeast cells. Some biofoundries are set up to work across this wide variety of cell types and organisms, but others are not. And then it costs money in hard infrastructure to be able to, develop that capacity. And then even if you're just talking about bacterial cells, it's often not possible to use exactly the same workflow for different species of bacteria. Sometimes you need to use a different pipette tip on the machine, which requires you to recalibrate the machine completely. Just the whole thing starts to explode. But of course, if you're a facility at a university, your university researchers are likely, each lab is working on its own projects with its own organisms and its own research questions. And so tempting them to come in and, sort of use your services, you in some ways have to be able to work on the variety of projects that they want you to. So this, tension led one biofoundry practitioner to reflect on the challenge of how to appropriately value and cost the work that they do. So this idea of working out how much you charge your client and then how much you absorb yourself. So, one very clear observation from visiting these foundries is that many of them offer an incredible amount of expertise and research guidance to researchers to teach them how to conceptualize their projects in ways that make them amenable to the biofoundry, and also to help them think through, what a useful product might be. And this isn't a trivial process. And not only that, but there might not be a clear incentive for a researcher to start working at a new scale. And this is a continual frustration on the part of academic foundries, that these researchers just don't realize what they could be doing with their work. And they're hiring postdocs instead of using us, like this kind of thing. Because, of course, all postdocs do nothing except for what the robots would do. But at the same time, it seems, like each project a biofoundry takes on involves a great deal of customization, and these costs can add serious sticker shock if you were to include them in your fees for researchers. So biofoundries often have to absorb this cost. And I think it's important to acknowledge the dual nature of this cost absorption, right? So first is the economic or financial side of absorbing costs. So to date and across the full spectrum of biofoundries that I've studied, it's pretty clear that the fees that both academic and commercial biofoundries charge their clients do not cover the costs of the projects that they're taking on. That's clear from the SEC quarterly filings and things too. So for companies, there's clearly a need to become profitable. For academic facilities, there is some push to at least be sustainable and cover costs, right? Academic foundries in particular seem to have been set up without clear business models. So one PI admitted to me that they really just had no idea what the demand would be when they initially wrote the bid to set up the foundry for their institution. Especially in the context of UK biofoundries, there was a push. They funded about 5 or 6, maybe 10 years ago now. The funders were not scrutinizing the broader business strategies. The focus was on what to spend the capital equipment. In fact, they weren't allowed to budget anything that cost less than £10,000. So you couldn't even buy the reagents to run the machines. You could just buy the machines, basically, and then had to figure out other ways of getting the supplies to actually run the machines. I think the other facet of this absorbing costs is the human side of things. So practitioners in biofoundries are in this difficult position of needing to sell the services of their facility and then having to do what it takes to make it look like the facility is working as smoothly as possible. And they work incredibly hard to make projects seem both doable and affordable. So I'm going to sort of turn quickly to some of the work that Annie Hemang did as a PhD student working with me. She finished her PhD in 2022, and before starting her PhD, she had worked in a commercial biofoundry. And then as part of her PhD, so she left that biofoundry and then studied them as part of her PhD. So she worked in she studied a number of commercial biofoundries. And she came up with this idea of routine interruption to describe the lived experiences of the machine operators on the shop floor. So this image at the top is an idealized representation of how a biological sample should move through a workflow. But what Annie personally experienced and observed was that when it comes to running actual biological samples through the system, operators would face what she called a degree of predictable unpredictability. So it meant they could never just sit back. Instead, there was constant troubleshooting under the surface just to keep the pipeline flowing in as linear a way as possible. And this troubleshooting typically requires a considerable degree of knowledge regarding the equipment, the software, and the actual biology of the samples being processed to understand what it is that's going wrong. And so Annie learned that it could take several years for somebody to become what they would call a mature operator of a workflow and be able to really troubleshoot anything that would come up, right? But this human labor is rendered largely invisible in the spirit of keeping this nice, clean pipeline model running, right? Which prompted Annie to write a paper on the trouble with troubleshooting and that she published last year in STHV. And she identifies this category of troubleshooting work as inherently problematic because it's always treated as this temporary phenomenon. It's not something you want to acknowledge. It's always labor that in principle should decrease or disappear going forward, rather than labor that really possibly should be acknowledged as core or central to how, in this case, a biofoundry works. But again, I don't think any of this is this is not unique to the biofoundry. This is just a site where we can see this happening. And this kind of invisible work, unsurprisingly, can result in frustrations on the part of biofoundry staff. So particularly in academic biofoundries, there's staff turnover seems to be a real problem. Staff often described feeling undervalued. They're paid as technicians. They're on short-term contracts rather than stable contracts a lot of the time. They could certainly be paid a lot more if they went to work in industry. And there's also a sense of frustration that the expertise that they put into making these projects work just isn't recognized, right? Especially when clients approach them with the attitude that they're just service providers, right? So it's this tension of I'm a service provider, but I'm providing you actually with deep knowledge and expertise, and kind of negotiating that because they're kind of letting themselves be positioned and sometimes actively positioning themselves as service providers, but in practice, the work is reasonably complex. So I think, for now, I'll just maybe sum some of this up with a quote from Anna Singh that I think captures a lot of what's happening here, which is, at best, scalable projects are articulations between scalable and non-scalable elements in which the non-scalable effects can be hidden from project investors. I'll say that when I've shared this observation back to biofoundries, it's typically been met with a nod, a smile, maybe a little bit of uncomfortable laughter. But I will actually say also that it was an automation engineer at a biofoundry who first directed me to this article. So this is one of these really interesting cyclical things where this community is very actively grappling with and trying to make sense of the work that they're doing. I've met many who are very well versed in relevant STS to their ideas. And so methodologically, this becomes interesting and potentially fruitful, right? So to start wrapping up here, I'll come back to this slide that I briefly flashed up earlier, where the CEO of Ginkgo Bioworks said earlier this year that the choice between scale and flexibility is a false one, and you can have both. So I think many of the observations that I've just shared do highlight some of these tensions between scale and flexibility. This slide is making the argument that because DNA is common to all life and that the equipment used to engineer biology is the same across different sectors of biotech, that scale and flexibility need not be a false choice. This kind of claim highlights commonalities, but it erases differences and non-scalability. It doesn't acknowledge the context dependency of biology, nor does it acknowledge the labor involved in designing and running different workflows using combinations of the same equipment. So my sense is that the CEO of Ginkgo Bioworks believes he can justify this claim because as a company now, they've spent 15 years going through these iterative cycles of building automation and data infrastructure and chasing clients. And in this talk, he does openly acknowledge that most biotech companies don't have the incentive to do this, that this is a space that they have kind of gotten themselves into. And then going through the accomplishments he presents in the rest of his talk suggests that Ginkgo might be reaching a stage where parts of its platform have reached sufficient scale, and that within these parts they can increasingly accommodate a diversity of projects for different biotech sectors. So that for example, in the realm of enzyme engineering, they have common processes in place now where they can both engineer an enzyme to be a better laundry detergent and a better human therapeutic. So to the extent that this tension between scale and flexibility has been resolved, my sense is that in practice it refers to this kind of small and selective area of overlap rather than a sort of broad resolution of these two ambitions, right? And presenting it as a false choice frames this in a way that risks ignoring or undervaluing actually the incredible amount of work and expertise that has gone into bringing these two spheres closer together. But this kind of erasure isn't uncommon in the presentation of scalable projects, right? So, couple of summary slides, just focusing on different levels of abstraction here. First, I hope to have made the case that biofoundries are a very lively site of reconfiguration. I started out by talking about how they're reconfiguring their internal elements to engineer biology at scale, but actually we see that the process of figuring out how to configure these elements requires you to simultaneously figure out how to build a market as well. And that this turns out to be a pretty complex negotiation both for the commercial and the academic foundries in the absence of clear market signals coming from them. So this is not, in many ways biofoundries are a solution looking for a problem, right? The services that they're in principle looking to provide are actually about changing the approach to biological engineering to explore a much bigger parameter space. I think this pushes them out of the territory of what we might think of as a typical service provider. I think this is sort of a position that they're struggling with. It potentially sets up more of a transformative relationship between provider and client than the transactional relationship implied by a service provider. I haven't talked about this today, but some biofoundries are also beginning to set up quite complex ownership models around data and IP that, again, moves them out of a simple service model, potentially entangles them much more with the future fates of their clients. Okay, to zoom out a step away from the biofoundries and think a little bit bigger picture about the politics of scaling some of these platforms. I think one of the challenges we see for biofoundries, along with other platform technologies sometimes, is that success or profit is only something that can be realized at scale. And that then the scale that you need for success is underspecified and always future-oriented in some way. So like what it takes to achieve that magic success is this ever-receding horizon, right? A recent paper by Sebastian Pfotenheimer and colleagues note that this kind of speculative scaling is a different economic model from the sorts of scalable businesses where you just make and sell more of the same product. It also does strike me as slightly different from the kind of sugar plantations described by Anna Singh. So she defines scalability as the ability to expand without rethinking the basic elements or the relationships between them. It's not clear to me that that's exactly what's going on here. It's also not clear to me that that is truly the case of what would be happening in a plantation setting. But anyway, I think this is something I'd love some help to explore and think through further. I also want to think further through the relationship of biofoundries and biological diversity. So on the one hand, biological diversity is framed as a resource to be harnessed, clearly aligned with supply chain capitalism, feed this in. But they're also not necessarily looking to flatten difference in the way that some scalable projects have, right? They're actually looking to sort of take the diversity that's out there and generate a very wide variety of products that might sort of capitalize on this diversity in interesting ways. So again, trying to sort of think through what that tension means and how it plays out, I think is worth exploring. And then finally, just to kind of zoom way out and think about this project in terms of some of the broader theoretical concerns. My sense is that biofoundries are an interesting site where the scalable and the non-scalable are being actively negotiated. Whether they succeed or fail or become something entirely different, I think the jury is clearly still out here. It's a rich empirical site worthy of our attention at the moment, particularly with the growing interest around US bioeconomy, right? So there's an executive order around the bioeconomy last year. There's a lot of investment starting to pour in. And then finally, coming back to this relationship between care and control, I'd like to suggest this is a productive lens for studying biofoundry development and possibly other sites. I realize that care and control are not terms I have used a lot during this talk, but the observations that I've shared and the fieldwork that I've shared with you are very much grounded in trying to trace the affective and political dimensions of the work underway and the relationships that are being forged. So I'm curious for your take as to whether or not you can sort of see those threads running through and whether it might be kind of more broadly an interesting analytic to apply to some of the case studies and things that you're working on. So I will stop there. Thank you so much. I hope we can have a fun conversation.
Well, I have lots of questions and thoughts, but I don't want to hog airtime. So Judiman's got one here. And Judiman, after you ask your question, can you run the VR microphone person?
Hi, Emma.
Hi.
Thank you very much.
Is it on?
I don't know. I think so. Yeah.
Okay.
Hi, I'm a third-year PhD candidate here in STS. Thank you so much. I really enjoyed. I mean, honestly, I did not understand much, but I have two questions. The first question is, I'm really interested in the hierarchy of labors in this thing. Like from your talk, I realized that although it's a biology thing, but there are biologists, there are biochemists, there are chemists, there are mathematicians, there are statisticians, there are engineers. So I want you to outline who are at the what kind of position in the ladder in this business. And the second is a methodological question. I saw that you have a PhD in biochemistry. So to what extent your this background helped you do this kind of study? And because I come from a pure social science background, so if I were in your situation, I don't think I would be able to bring that many nuances. So if you could answer these two questions. Thank you.
Sure, two great questions, yeah. So thinking about the sort of, your first question was really about sort of the hierarchical ladders, right, that are in play. And I think one challenge to answering this question well is that I'm looking at biofoundries of very different sizes. So the academic ones are like, 4 to 10 people, often 4 or 5 people, right? And actually in those spaces, you have actually a PhD student in Edinburgh who did some work around this. He called them amphibious researchers who basically have to be comfortable living in both wet and dry environments, where individuals really have to take on a lot of the full work. But there has typically been, and there's definitely an attempt to try and separate out design phases, build phases, and test phases of the work. There's often a discussion of having an iterative loop where you would go design, build, test, or insert learn into it. This is an ongoing topic of whether they're learning from what they're doing or not. Some biofoundries are, some are not. There's sort of a separation where actually I think it's the build work that gets most devalued. That is sort of the technical work of making the constructs. The design work is the ideal. And so the whole thing is like, in principle, we should be freeing up people's time not to do the mundane work of assembling DNA, but to do the designing of the future world that we want to live in. And so there's a valuation of design over build, and the testing part is hard. The testing is like, it depends on every time you need a different test because it's like, what are you looking for? And so the test part is hard, and I think that one gets a little bit lost in the design build, sort of split. Some of the bigger biofoundries physically separate out people as well in that way. And I think, and then the build is usually the build and test are the individuals who are on the shop floor engaging with the machines, right? And they do shift work. they don't always, most of the biofoundries don't operate 24 hours a day, but a lot of the commercial ones certainly have like a 12 to 16 hour operating window. And so there's shift work. There's interesting conversations where I was talking to someone too, and they couldn't get a desk because you could only get a desk if you were there like certain number of days a week, and that count like the sort of again the sort of precarious, like he was working 40 hours a week, but it wasn't in like the official time slots, and so it couldn't get it right. Yeah. So there is that kind of hierarchy. I don't know if that fully gets at your question, but you can see it. You can see it there. And then methods-wise, yes, I would absolutely say my scientific background it puts me in this interesting position of, I think, and having followed this field for 15 years as well, of sort of understanding a fair bit of the technical efforts that are going on. I will say, I mean, these days I am completely lost with a lot of the like really, especially some of the AI-driven things that they're doing. But I think it helps to have conversations, and it helps me to identify pretty quickly the things that are bugging them, and how one of the things I'm interested in doing is kind of making these connections across spectrums, like I was saying, of like specific technical choices that are being made on the shop floor, and how that shapes the trajectory of the biofoundry in terms of what, like, you know, well, this pins them down into doing work with bacteria, which means they can't do this kind of work, which means they can't, right? And so I think that technical background does help sometimes to be able to isolate which the critical, you know, sort of which the critical design choices and things like that are.
Hi, my name is Dong Lee, a visiting scholar of the STS here, and was very interesting inside for presentations. I really appreciate it. And my question is, when talking about the relationship between the sort of like scalable and non-scalable elements, or the control and the care.
Yeah.
Like you mentioned that, you know, care is a lot of depends on the context, right? Yeah, I'm very much agree with that opinion. And what I'm curious about is that, like, for example, when you're talking about the human cognitive ability, human cognition, I think that it's very influenced not only my own biological condition, but also influenced a lot of our environment surrounding me. So, and I think like we human interact with a lot in my perspective. So, in addition to the kind of surveying or interviewing the clients, I mean, I'm talking about the process or the stage of manufacturing the bioproduct. At that time, is there any like specific way or method to capture that characteristics? I mean, like interaction with the environment for the products?
Interactions between the products and the environment, or the
like,
clients and the?
Yeah, I mean, like the stage of the manufacturing of a bioproduct.
Yeah.
How can we like put that characteristic into the products? Like, is there any like specific method or any way to make it realize it? Like,
Of a specific kind of product.
yeah, specific way or method.
To build it. Well, I think, I mean, I'm trying to understand so that I can, this is the types of product, or how you might design values into the types of products that you're.
Yeah, it's like kind of, sorry for the ambiguous bit,
Yeah.
ambiguity, but I was just wondering that, you know, when you make the bioproducts, you interview the clients or. Like, or just asking some questions.
Yes.
But I just wonder that, you know, not just the interviewing the clients. When you actually manufacturing the bioproduct, how can you put that questions and characteristics into that products? Like,
I mean, this is a really kind of iterative process, right? Too, and it is. I think, you know, that what happens, and I've seen this. Different biofoundries are taking very different approaches here. Some basically are like, just tell us what you want us to do, and we'll do it, right? And others actually undertake really extensive scoping with their clients that touch on several different things. And so obviously just technical feasibility is a big focus, but then all kinds of other questions come into play. Depending on the scope of the foundry and kind of how they imagine themselves contributing to the future as well, most of them do basic sort of security checks, as it were, that the DNA that they're working with is safe to use. And there's kind of algorithms and you can run through. There's services you can use to kind of check the DNA for known pathogens and things like that. There's sort of bigger sets of questions around what are the kinds of projects that we want to have in the world, which is a very interesting and challenging set of questions because, of course, right now you're chasing as many clients as you can, but you're also building infrastructure that will address the wishes of those clients. So it matters which clients you take on because the infrastructure that you build will facilitate those kinds of futures, right? And so I will say, the company Ginkgo Bioworks, for example, has a process by which they do risk assessments or business assessments of every product, of every client that they're looking to work with, that asks several kinds of questions about what sort of future does this enable? Is this a future that we're happy with? Who gets disadvantaged through this future? And it has very lively conversations about what the future of biotech could and should be, where they're unresolved questions but ongoing debates. So do we want a future for biotechnology where we are generating synthetically produced dairy and meat products as a way of combating industrial agriculture? Do we see that as something we want to support or not? And what are the effects of doing that, and so on. So I don't know if this is getting at your question, but there is, there's sort of different levels, and I've seen across the foundries everything from like, just hand us your stuff and we'll do it, and we'll just run the basic screens to make sure we're not synthesizing viruses, to kind of much bigger conversations about, are there types of projects we just would not work on? Are there types of projects and futures we would like to bring into being? And how would we do that?
Sorry, this is a little complicated. The notion of the metaphor of a foundry is both a historical metaphor and a technical metaphor.
Yes.
And I guess my question is, how accurate do you think that metaphor is, both on its historical context and in its technical mode?
I haven't looked into this in detail. It's something that I have had a student who's done a little bit of digging. Another word that sometimes used to get used, I think biofoundries has kind of crept in as the default word, but for a while they were also being called biofabs, so with allusions to like semiconductor fabs. And I think, again, it's like, what are the parallels there and so on, right? To my understanding, and I would love to sort of have a sidebar project that really digs into this. Well, foundries were like noisy, messy, hot, industrial spaces, right?
Right, they're also the thing that produced Frederick Taylor. So.
Right, yeah, right. And so, a lot of, in the early days of some of the biofoundries, they read a lot of the like Lean Sigma 6,
sure.
It was like built into their, sort of like their way of thinking about how they were going to organize themselves, divisions of labor and so on and so forth. Increasingly, the commercial biofoundries were turning more to thinking about like big tech, like Amazon cloud services and things like, so it's sort of, again, which models turn out to be the most relevant or appropriate metaphors for their work. From what I've seen, that has already shifted the companies that they invoke seem to change on a sort of like biannual basis. And I haven't dug too deeply into exactly how that reflects their changing practices, but I think that would be a fascinating, sort of thread to follow. It's like, well, why were you reading Sigma 6 10 years ago? And why are you reading like, the Amazon guy's book now? And why are, and how is that reflecting changes in the process? Yeah.
Could you make a timeline of that?
I could pull out the different, I could pull out that. I think that would be an interesting, like, to just see who they're invoking and why. I think that would be a great little side project, because I have, now that you mentioned, it's like I've seen the different companies emerge.
Is what is real? Like, there's a lot of what you're talking about at the technical level
Yeah.
that really strikes me as foundry-like.
As Foundry, yeah.
Go ahead.
Thank you so much for your talk. I found it fascinating. I think that more and more these days we think of biology and the human system as almost like a computer and our DNA as code, where it's a simple system. I think even the term wetware that you used is like analogous to software or hardware. And in a way, I'm wondering, like, there's an element of like feeling like there's a dehumanization involved in that. And I know you talked a little bit about care and control. I'm curious if you could elaborate on care of what, I guess, or like control over what? I don't know if that's clear enough.
Well, and I think this is it. It kind of runs through lots of ways, but I think you're right. I mean, there's something here that is about, there's something about, taking, it treats life on Earth as DNA, for one, right? It kind of reduces existence in a way to that, and then says we can even decompose DNA and we can create all these functional units, and then we can recombine them in ways to create these functions, and like, isn't that great? Or like, look, nature has produced animals that can do this. Why don't we look at all these animals that can do it and take their genes and then use it to make a product and so on? And there's something, I don't even know that it's necessarily dehumanizing, but also like de-livening. And these aren't just humans that they're, actually most of the organisms are not humans to which this is happening, right? So there's a commodification of the living world that is doing so by like reducing it to code, right? That I think we shouldn't lose here. And it is interesting to see the ways in which biology asserts itself and bites back and does not allow the foundries to sort of easily develop really sort of scalable infrastructure that allows you to work across all organisms, because you can never get rid of the organism. So you can abstract it, you can put it in a database, and you can annotate it, and you can make it kind of seemingly interchangeable, but it turns out that it really matters. and people within the biofoundries are like, no, it turns out it really matters. And so I think so I think this is where this sort of interest in sort of, the politics of like, who is deciding this? And this is a resource. I mean, in a way, these facilities are capitalizing on the huge amounts of genetic information that are available in public databases, and then also creating their own proprietary databases based on the sequences that they're, kind of generating. And so there's questions about, the commodification of life, the ownership of life, the who reaps the rewards of doing this, what kinds of futures are enabled through it, and are they futures that celebrate and sustain those lives and relationships, or are they futures that don't, right? And so I feel like it's hard to provide really straightforward answers to those questions, but I think that
Can I ask a follow-up?
Yeah, sure.
Which is, you mentioned the sort of like the teams that are designing versus, and then the teams that are making. These questions that you've just brought forth, is there a team that is considering sort of the ethics, the consent, the ownership? Is that different from academic biofoundries to commercial biofoundries? Where are these conversations happening?
I would say I have seen differences between academic and commercial biofoundries in a couple of different ways. I would say the conversations around ethics, broadly speaking, are not happening as much in academic foundries. They're much smaller organizations, and they often basically are just taking on bite-sized elements of research projects that researchers have secured funding for already, and to them, the conversations about the projects are often academically driven, whether or not they're directly intended to produce a new product for the world. They're often not necessarily doing that. And so I feel like I have not seen those conversations happen too much, but I have encountered a couple of biofoundries that are academic ones that are thinking about that. The commercial ones, yes. And then the question becomes, where and how do you build that in? So we have this long tradition of separating out the ethical, right? And so, do you have a team that does that? Is it something that should be inculcated throughout the entire, business operation? How does one do that? Ginkgo Bioworks has what they call a caring committee that was elected within the company and represents diverse sectors of the company and has legal counsel and so on as well. And so it's very interesting. And I didn't talk about that at all today. I've been following the travels of this committee, why they call themselves the Caring Committee and everything like that. So they are explicitly trying to do this, but also very much struggling with what is their authority here as well, because as a group of 10 people in a company of 1,200, what authority do you have? And so, this question of how and where you do that kind of ethics work is a really challenging one.
Ginkgo Bioworks,
Yeah.
That's a publicly traded company, right?
Yes.
And so
Yes.
the accountability question for me comes up in terms of
Yeah.
who are you accountable to as a service provider?
Yes, absolutely. And so thinking about, so if they're as a publicly traded company, you have to file a environmental governance sustainability report every year. Theirs is titled Caring at Ginkgo. You can take a look. And who you are accountable to becomes this very interesting question, and how you manage. One of the things they have done as a company is they call them bioworkers, the employees. They actually have a worker ownership model that they say has never been done in tech before, where the workers they own 10x vote shares, so that they in principle could prevent a takeover of the company from an outsider whose values didn't align with theirs. And now they're also struggling through how do you not just give that power in principle, but cultivate a culture of ownership that would want to exercise that power in a way that would shape the company.
Yeah.
So
Very interesting. Yeah.
Yeah. So I'm Yan, and also the third PhD student here. And thank you for giving a talk about Biofoundry. It's not only brings some of my enthusiasm on the lab study in STS, but also I'm very fascinated by this term foundries, because like Matt mentioned, when you mention about foundry, then you will come up with the semiconductor foundries. So my question is more on the on the economy side, or the scale of these biofoundries, because at some point from your descriptions that those biofoundries in the academia, they are in the university, they are more like a machine shop, if they're not be very offended. They're just like a machine shop that I just want someone to help me build this strand of build this single strand gene, then maybe somebody help me out. But for the commercial levels of biofoundries, I'm just like curious about their scale, and do they kind of like build some kind of ecology, or have some industrial complex that they also have their vendors, they also have tech support to help them troubleshooting their equipment, and how they do their pricings? Is it just like case by case, or just like you said, that you just hand your project to us, and then we will solve all the project for you. You will just be a turnkey solutions. Just like So I think my question is focused on the scale and also on the non-scalabilities, because again, if I only want one batch, or just like maybe one microliter of single-strand DNA, then yes, probably I can ask somebody else to help me produce. But if I want the batch or I want a case of single-strand DNA, then there will be a different stories. So that's my question about the scale, and I would say the industrial ecologies of those biofoundry today. Thank you.
Great set of questions. I won't have time we could chat a lot about this, but I'll give you a couple of sort of snippets or insights for this. One is that some of the academic biofoundries, right? In principle, they want you to be working at the level of thousands, right? And some of them say, our minimum order size is 24 samples, right? Because this is what academic researchers work with. And when I've talked, again, I mentioned offhand this sort of study of curious and skeptical non-users that I've also been doing. And so I've been asking them about, they're curious, they might be interested in using a foundry, but like what's stopping them? And sometimes they'll say, well, look, this is not how I do my work. The way if I have a project, I'll make 10 things, and I'll test those. And based on that, I will design the next 10. And based on that, I will design the next 10. And so for me, doing 100, I might, by the end of the project, have done 1,000. But I'm not going to put the time in up front to do that because that's not how I work. And even if I got the 1,000, the testing would become the bottleneck because I just can't test the 1,000. It would take me that long anyway. So I structure my, the cadence of the work that they're proposing doesn't necessarily fit with the cadence. That said, what a lot of the foundries do then is try and the pricing. I mean, it's a dark art. And often it boils down to what does it cost to run the biofoundry, like for the academic facilities, what does it cost to run the biofoundry? And how do we retroactively calculate what the cost of a sample should be based on that, based on a guess of how many samples we're going to get in a given year to do. And so they come up with a magic number, and then that magic number changes from year to year. And then, and so because they want, people also, the skeptical users, non-users, want some sense of what it's going to cost them to do this. And so again, if there's nothing on the website that tells you how much it's going to be, and then this number is just going to appear as part of your quote, that's also challenging the ability to kind of do that work. Same with the commercial biofoundries. I think what happened typically was that it would be very much a case-by-case basis and you would be handed a quote. Increasingly now that, I think it's one of these things where once you reach a certain amount of scale, they're starting to group together and figure out what some core, slightly more standardized offerings can be, and those have slightly more standardized prices.
Right.
Yeah.
Lyndon.
Thank you so much for your talk. I'm also a third-year PhD candidate. So I'm really interested in this concept of care and control. And so I'm kind of going to explain like how I'm understanding how you're using it, because you said you wanted to just see if we picked up on the kind of themes. And so I see the care and control as crucial to the construction of value for these, for biofoundries and like creating a market for themselves. And kind of picking up on this narrative of designing a future that we want, and like that's like a form of care in a way. And to like, caring for a future that we want to design and control. Is that what you were kind of alluding to throughout your talk, or is it? Am I off base?
I think there's absolutely aspects of it, right? So there's the sense in which, and I think this relationship between care and control, I certainly do not mean to sort of oppose them, but I think they're this sort of really interesting conversation, right? Where sometimes it's like, if you care deeply about something, you're invested in it, but you also are in it with others. And so the degree to which one individual should have all the agency in this process, right? Like it becomes this tricky situation of like, who gets to decide what the future should be and what products you should, or which, and you're not responsible for the products, right? So this is also the case where the sorts of responsibilities become really challenging, because you could argue as a platform that like, well, we just made this for this person. We didn't know they were going to go off and do this other thing with it, because you actually also can't really control. You can't control what others do, nor can you completely control the biology, right? And so there's this sort of desire to, the engineering impulse to control and to create a better world, often I think, minimizing the negative effects or the unintended consequences, of which we always know there are as well, right? So I think some of this is also about the engineers coming to terms with the fact that there will be unintended, that they know, sort of recognizing that they don't have complete control here. And so how do they do this process, right? And so I think I'm just sort of reflecting back to you as well. I think you're right, this kind of framing of, and especially with this caring company, for this caring committee, I mean, it's fascinating because a lot of it is about control. Like, can we implement legal guardrails to prevent them? Like, okay, we are going to work on this project because we think we can do it and because we do see their value in producing this, but we also see how this could be used for this other thing, and so we will put a guardrail in there. Well, that's arguably a form of control, right? Coming from a place of care, but what kind of partnership is it creating as well in that process, right? Is it purely a client-based thing? Are you trying to help work with that client to reshape the world in a better way? Do you want to check whether your values are aligned? Like, do you want to have the hard conversation about, would you actually use it for this and be confident about that? Or do you just want the legalese in there to make sure that you're not responsible if they do, right? Like so there's lots of those kinds of questions too, where I think they're related, but also in tension with one another at that kind of slightly broader scale.
That was great. And Lyndon, thank you for doing that. That was very helpful to
Yeah.
kind of
Okay.
say back. Yeah.
Hi, thank you so much for your talk. My name is Sierra. I'm a prospective student, just sitting in. But I was also very interested in like thinking about the framework of care. And I was just kind of wondering if you, and the answer could be both, but I was kind of wondering how you were thinking through care with like either it being a reconceptualization of like how these biofoundries, like the existing work that's happening, saying like this is care work and that takes expertise, as you were talking about your PhD student and the troubleshooting and how that requires expertise, or like using care as a way of kind of auditing, or like the care team that you were talking about. So like how, especially when thinking through like Toronto's framework specifically, and how they might not have control over what they're doing and how like you can't exactly control what you're caring about, if you will. I don't know. That wasn't a very concise question.
Well, I know this is the thing. Is partly too is I would love to say I had this like really well defined. Part of me was like, I feel like these are interesting threads to follow, and that they get manifest in so many ways too, right? Like you could argue that the division of labor and the hierarchies that are, that are being instituted give different individuals on the, like different degrees of control and investment in their work as well, right? And so it's kind of like, it's like at what level and in what places. And so it's one of those things where I've sort of, been trying to sort of keep an eye out, but thinking through affect, thinking through the sort of charged, things that seem charged, things that are moments of frustration, moments of joy, so, the sorts of, the cadences of things that people are worried about and so on. And then, trying to kind of piece from all of that, what's mattering in this space, right? And how's that being pulled together? And I think it kind of plays out, like there's no one simple definition of it, right? It kind of plays out differently, and kind of allows you then, but certain things where you could be like, yeah, look, we've done all this, and turns out that troubleshooting is really important, and maybe as a company, this is something that you could find ways to celebrate, right? Or that you could find ways to acknowledge that might change the dynamics here, because in trying to brush troubleshooting under the carpet, that is a move of control, right? That devalues the work that's being done, and therefore has consequences for the lived experiences of those doing the work, and possibly also has consequences for like you may not be best learning from this, right? And so possibly has consequences, in multiple ways throughout the company. So.
Oh man, I want to ask you so many questions, but we're out of time, actually. And I want to kind of respect time. So Emma, thank you so much for hanging out with us. And let's give her another round of applause. Folks here in Blacksburg, we are going out to Eastern Divide. I'm going to get there around 4:30, but I'm just going to say like 5 o'clock start.